good afternoon. This is Professor David J. De Los Reyes. My topic this afternoon will be a new topic. So, for those who are taking up engineering and now on the course differential equation, this is for you guys. Another example problem on a third order variable separable differential equations. This will now be example number 8. There are many problems in variable separable, so I will saturate you with example problems before we will go with the application problems of variable separable differential equations. Okay, let's proceed, guys. My topic this afternoon on my channel under Professor David J. De Los Reyes on YouTube. This will now be DE09, Differential Equation, lesson number 9. The title of the topic is Differential Equation. I am now on the third course on my channel. My first course was Differential Calculus, second was Integral, and this is the third course. Plus some other things on the electronic things on the short videos. Differential equation, still third order. The example yesterday was third order, but it's another problem. So I will give you another variation for third order variable separable differential equation. This problem is just an evaluation problem, but there's a so-called variation from the previous examples. So I will try to explain to you now the problem. Okay, I will give you the problem. We are given d cubed y over dx cubed equal to 24x minus 5 cosine of x over 2. We are given this differential equation here. And the problem is asking what will be y as a function of x. This is power 3. Okay, but don't be afraid with this one, because I will tell that the derivative with respect to x of y is actually equal to y prime, and the derivative with respect to x of dy over dx is equal to y double prime, and the derivative with respect to x of d square y over dx square is actually y triple prime. My subject matter yesterday involves the prime. It is y prime, double prime, triple prime. But the equivalent of this in terms of dy dx are these. Okay? And do you know that the equivalent of the derivative with respect to x of the second derivative is actually d cubed y over dx cubed? It is the given problem. Oh. So meaning the required y as a function of x is actually was taken the derivative 3 times. That's why the power of this is 3. We will read this d cubed y over dx cubed. That's the proper way on how to read it. Okay? Okay, I will try to erase this one so it will look good. It's still an evaluation problem of a third derivative, you know, before we will proceed with the application problems. There are many application problems under variable separable, so I would like to saturate you first with so many evaluation problems on variable separable, but they were different from each other. Okay, let's proceed with solution. The solution will be something like this. The derivative with respect to x of the second derivative is actually d cubed y over dx cubed. Okay? That's by definition. The derivative with respect to x of the second derivative is the third derivative of y with respect to x. It is the given problem. So from the given equation, we will substitute this equivalent here, back here. So the derivative with respect to x of the second derivative is actually the third derivative. And this should be equal to 24x minus 5 cosine of x over 2. We are given a combination of an algebraic function and a trigonometric, and we are given an angle here, x over 2. So it will be a little bit complicated, but it's not so complicated. Okay, let's try to multiply. Let's try to multiply all terms by dx. Okay. Let's try to separate the variables. The main topic is variable separable. Okay, so the left hand side times dx, this dx here, cancel with this. What will remain on the left will be the differential of the quantity second derivative of y with respect to x, equal to the right hand side times dx. So after the multiplication of dx, okay, we could say that we have already separated the variables. Variable separable, okay? That's the name of the main topic. To bring out the second derivative, take the integral of both sides. We will integrate this one, guys. After the separation of variables, try to integrate. Therefore, the integral of the differential of the second derivative equal to the integral of the right hand side times dx. We are now integrating, right? The left hand side, when this integral goes near this differential sign, they will try to cancel out each other. So what will remain will be the second derivative. And this should now be equal to. We can now proceed with the integration on the right hand side. But take a little bit step easy, okay? Those integrable, that's very easy, integrated now. For those who are a little bit complicated, take your time to integrate. The integral of 24x dx will be power formula. This should be 24 x squared over 2. For the cosine function, there is a formula on how to take the integral of a cosine function. But let's try to verify the differential of the angle. The angle is actually x over 2. And the differential of the angle should be 1/2 dx. So if we try to inspect the second one, we don't have the 1/2 over here. So we will place 1/2 over here. Then we place a 2 outside for it to be integrable. So the integral of the second part, after the verification, this should be -5. We insert the 2 because we put our 1/2 over here. The integral of cosine of x over 2 times the total differential as per verification, it should be 1/2 dx. That's why we place 1/2 over here. To counter that, we place 2 outside because 2 over 2 is actually 1. We are not changing the value of the integral. Therefore, the second derivative of y with respect to x, the left hand side, equal to 12x squared. The integral of cosine is a plus sign of x over 2. So, sorry for that one. Plus sign. 5 times 2 will be 10, and the integral of cosine is sine of x over 2. Say sine of x over 2 plus k1. Okay? That's the first part of the solution. But that is still second derivative. It's not yet y as a function of x. Okay? And again, by definition, the derivative with respect to x of dy dx is actually d square y over dx squared. So we will replace this value here by this equivalent. Okay? I will erase this one. So continuing with the solution, the second derivative of y with respect to x can be written as the differential with respect to x of the first derivative equal to the right hand side. Okay, then try to separate the variables. We multiply all terms again by dx. dx times the left hand side, this dx here, cancel with this. So what will remain on the left will be the differential of the quantity dy dx equal to the right hand side times dx. We separate the variables already. Okay, proceed with the integration. Try to integrate again both sides. The integral of the differential of the first derivative, integral goes near this differential sign. They will try to cancel out each other. Okay? Yeah. They will try to cancel out each other. So the left hand side will now be simply dy dx equal to, for the right hand side, it involves sum and difference of integrals. 12x squared minus 10 sine of x over 2 plus q1. Try to expand, then try to integrate. This is easily integrable. q1 dx is easily integrable. Sine function is still integrable, but we must have try to compute for the exact differential. For this sine function, the angle is actually x over 2. du will be 1/2 dx. It is not exact. It does not have a 1/2 inside. So let's continue with the solution. dy dx now equal to, for the first one, power formula, this is 12 x cubed over 3 minus 10. Okay? We place 2 outside, then we place 1/2 inside, then take the integral of sine function. The integral of the sine function is actually negative cosine. We insert this one because we place 1/2 inside, right? So, and the integral of sine is negative cosine of x over 2. The integral of q1 dx will be q1x plus q2. So, simplifying now, dy dx will be 4x cubed minus this should be plus. This is 20 cosine of x over 2 plus k1x plus k2. So this is now the first derivative after the integration. That's a part of the solution. That's why we got a second constant k2 over here. That's after the second integration. After the first integration, we got the k1. After the second integration, there should be another constant, that's k2. And that is actually dy dx. And again, by definition, the derivative with respect to x of y is equal to dy dx. So the dy dx on the left can be written as the differential with respect to x of y equal to the right hand side. This should be close bracket. Right? Then try to take the integral of both sides. Let's try to separate first. And to pass. Okay. We multiply all terms by dx. So the left hand side multiplied by dx, this dx cancels. Right? What will remain will be differential of y equal to the right hand side times dx. Then try to integrate both sides. The integral of the differential of y will be y equal to, for the right hand side, don't be bothered with it. It contains four terms. 1, 2, 3, 4. This is easily integrable. This is integrable. This is integrable, and this is integrable. We got a problem here. We insert the 2 outside for it to be correct. So what will come out? Y now will be, the first one will be power formula, 4x to the 4th over 4. The second part will be 20. We insert the 2, and the integral of cosine is sine of x over 2. The integral of k1 x dx is actually k1, power formula, x squared over 2. And the integral of k2 dx will be simply k2x plus another variable constant k3. because we integrate it for the third time. There should be a constant of integration subscript number 3, K3. So simplifying the answer now, this 4 cancels. So y now will be x to the 4th, right? 20 times 2 is 40. Sine of x over 2. What's next? 1 half k1 x squared. Okay? And the last part, k2x, I'm missing a part of the final answer. This should be plus k3, okay? The second to the last is k2x plus k3. So this is k2x plus k3. Okay, guys? That's the final answer. Okay, I will try to rewrite the final answer. The final answer is actually y equal to x to the 4th. What's happening? Plus 40 sine of x over 2 plus 1 half k1 x squared plus k2x plus k3. So this is our final answer. So this is now y as a function of x. It will still be a general solution. Why? Because for the meantime, there are no initial conditions given because we should have computed for value of k1, k2, and k3, and since they are not given, our solution is actually a general solution. So this is the final answer. I will read the final answer. Y is equal to x to the 4th, 40 sine of x over 2, plus 1 half k1 x squared, plus k2x, plus k3. Okay guys, that's the solution of the problem for this afternoon. Just take the separation and integration gradually. First separation, first integration, second separation, second integration, third separation, and this is third integration. And after the third integration, we come up with the final answer, and this is the final answer. Good afternoon, Los Angeles.